Welcome everybody to this semester's Deep Learning lecture. My name is Andreas Meyer and I will walk you through this lecture series. So you can see again that we are still not in the lecture hall, but you can see me here in my home office. We decided to make those videos again available for online learning. You know, the pandemic is still going on. Many of you can't find the way to our lecture halls. Some of you are still stuck in visa trouble, so you can't even enter the country. Some of you are already here, but we try to avoid to fill our lecture halls with so many students, so we decided to keep up this format with online video lectures. Again, we chose the format of 15-minute video lectures because they are much easier to consume, and we will release those videos again almost every day, such that you can also easily follow the lecture. In total, we will have 65 videos, and you can see that when the semester runs from the start of November until approximately mid of February, then you can already guess how many videos you should have been watching during this entire period. So I hope you will find these videos here interesting and joyful.
Fascinating.
Again, we will have two versions of the video series. We have one version that has quite a few memes that should be a little bit of refreshment during the scope of the video, and we will provide a second version that is not contaminated by any memes. In case you find them distracting, we will just cut them out and you have this second version that doesn't have any of those distractions. Okay, so thank you very much for tuning in, and this means we are ready to go with our lecture. This first lecture will be about the introduction into deep learning. We will deal with a broad variety of topics in this lecture. First and foremost, of course, deep learning. We summarize some of the buzzwords here that you may have already heard. We covered topics from supervised to unsupervised learning. Of course, we will talk about neural networks, feature representation, feature learning, big data, artificial intelligence, machine and representation learning, but also tasks such as classification, segmentation, regression, and generation. Let's have a short look at the outline. So first, we'll start with a motivation and why we are interested in deep learning. We see that we have seen tremendous progress over the last couple of years, so it will be very interesting to look into some applications and some breakthroughs that have been done. In the next videos, we want to talk about machine learning and pattern recognition and how they are related to deep learning. And of course, the first set of lectures, we want to start from the very beginning. So we will talk about the perceptron, and we will also have to talk about a couple of organizational matters that you will see in video number 5. So let's have a look into the motivation and what are the interesting things that are happening right now. First and foremost, I want to show you this little graph about the stock market value of NVIDIA shares. You can see here that over the last couple of years, in particular since 2016, the market value has been growing. One reason why this has been tremendously increasing is that in 2012 the deep learning revolution started, and this really took off approximately in 2016. So you can see that many people needed additional compute hardware. NVIDIA is manufacturing general-purpose graphics processing units that allow arbitrary computation on their boards. In contrast to traditional hardware that doubles the computing capabilities within every 2 years, graphics boards double their compute power within approximately 14 to 16 months, which means that they have quite an extraordinary amount of computing power. This enables us to train really deep networks and state-of-the-art machine learning approaches. You can see here that there is a considerable dip around 2019, the end of 2018. You can see that it's not only deep learning that is driving the market share of NVIDIA. There's also other very interesting things happening at the same time, and one particular one is Bitcoin mining. The Bitcoin value really decreased at that period of time, and also the Nvidia stock market value went down. So it's particularly associated to the Bitcoin, but you can see that the value is going up again because there's also a huge demand for compute power in deep learning. Now, what are the interesting applications that we can aim at? So the big bang of deep learning came with the so-called Imagenet challenge. This is a really huge data set, and this huge data set has approximately 40 million images labeled into approximately 20,000 synonym sets. Emerging from this is the so-called Imagenet large-scale visual recognition challenge that is using approximately 1,000 classes. Before the Imagenet challenge, classifying into 1,000 classes was essentially deemed completely impossible. The images that are used have been downloaded from the internet, and they have a single label per image. So this is really a huge database that allows us to assign categories to a large number of individual images. Now in 2012, there was this big step ahead with the win of the Alex network. AlexNet really halved the error rate. So if we look at the different error rates that we have obtained over the scope of the Imagenet challenge, you can see that we started off with error rates of about 25% regarding the top 5 error. So in 2011 and the years before, we were approximately in the ballpark of 25%, and you could see the stalling over the last couple of years. Well, in 2012, the first convolutional neural network, CNN, here was introduced, and the CNN almost halved the error rate. Now that was quite a big surprise because nobody else could do it at that time. You can see that not only in 2012 there has been progress, but in 2013 and so on, the error rates were more and more decreased until we essentially reached a level where they are approximately in the same range as humans. So the neural networks reported there are the first results where people have been claiming that there has been superhuman performance. So is it really superhuman performance? Well, not so many humans actually have evaluated the entire test set. So you could say that superhuman performance should be rather a super Carpathian performance, because he actually went through this entire test data set. Now, is there a problem? Well, yes, there are a couple of problems with Imagenet. Well, on the top row, you are probably seeing rather easy cases, but if you look at the bottom row, there's a couple of really difficult ones as well. So where you only have parts of the image shown, or in particular, if you have a look at the cherry that also shows a dog, it's very hard to differentiate those images. And of course, this is a problem if you only have a single label per image. Maybe a single label is just not enough to describe an entire image. All of these things are being used in industry right now. There's a huge number of deploying users, ranging from Google, Apple, IBM, DeepMind, but there's also other companies starting here. So you can see the Netflix challenge has been solved partially with deep learning. This was a $1 million challenge to actually build a recommendation system that will recommend movies that you actually like. And you can see that healthcare is going in there as well. Siemens and GE are also very interested in this technology. but also car manufacturers such as Daimler and many other car makers are going there because this huge trend towards autonomous driving. Let's look at a couple of really nice breakthroughs. So for example, people have been trying to beat humans in various games, and we already know since 1997 that we can beat humans in chess. So in 1997, IBM's Deep Blue was able to beat Garry Kasparov, who is a world champion in chess.
I mean, I played Kasparov because we both gave lectures at this same event, and he was playing 30 people. I forgot to mention that. Not only did he crush me, but he crushed 29 other people at the same time.
But solving chess is a little easier because it has not so complex moves. The way how they actually solved the game is that they had a dictionary of starting moves, then they essentially did a brute force search over the entire game in the mid part of the game, and towards the end of the game, again, they were using a dictionary.
I actually played the predecessor to Deep Blue, Deep Thought, I believe it was called, and that too crushed me.
Now Go is a much harder challenge because in every move of the game you can place a stone on every part of the board. This means that if you're really interested in doing an exhaustive search and look for all the different opportunities that you have in the game, only after a couple of moves the actual number of choices is exploding due to the large branching factor. At present compute power, we are not able to brute force the entire game. However, in 2016, AlphaGo, a system created by DeepMind, really beat a professional Go player. In 2017, AlphaGo even surpassed every human by only playing against itself. Then shortly later, AlphaGo Zero generalizes to a number of other board games. They even manage to go towards other games that are not like the typical board games. In AlphaStar, they beat professional StarCraft players. So it's really a very interesting technology to look at. In Google's Deep Dream, there was an attempt to understand the inner workings of the network, and they were interested in what the network dreams about when they present images. So the idea was to show some arbitrary input images or noise as input, and then instead of adjusting the network parameters, they tweaked the output towards high activations of the network. This creates, depending on where we're looking at, very interesting images. So you can create very impressive mystic images as shown here on the right hand side, with this input and the improvement by the network. Or you can even look at the blue sky and then tweak towards neurons. Then you can see that there are all kinds of interesting things suddenly emerging in the sky. If you look at them very closely, you can see that there are animals showing up, like the admiral dog, the pig snail, the camel bird, or the dogfish. So what else is interesting? Well, there's also real-time object detection that became possible with approaches like YOLO, you look only once. They use multiple areas and detect bounding boxes and classify them very, very quickly, and this runs in real time. It's not just working on individual scenes and images like Imagenet, where you only have essentially one object per image, but it works on completely cluttered scenes. You can even see that these detectors work on unseen input like movie scenes. Now you may say these are very interesting examples, but can we use this every day, or is it just research that produces fancy videos? It really works well. You may have seen that speech recognition interfaces have been improved tremendously. Also, with deep learning techniques, Siri's speech recognition is now in the range where it recognizes approximately 99.7% of all the spoken words. So in 100 words, there's less than one word that is being misrecognized, and you can see Siri is being used. Many people use it on their phones, they use it to dictate, and it even works in various environments. Also in environments on the road when you're outside of your house. And there's even background noises, and Siri still works. At least in most cases.
Siri, what time is it?
It's time for you to get a boyfriend or you will turn into a lonely cat lady.
Siri, call boyfriend.
Which one, Joe, Thomas, Charlie, Michael, or Pat?
Oh.
There's also very interesting stuff that's being deployed right now by Amazon. You can see that this is the Amazon product that many people now have in their homes, where they can remotely control different things. They can order, and it typically works very well, but of course, users that have like a rather strong accent still experience trouble.
Alexa, play Something's Cooking in My Kitchen by Dana on my Spotify.
I can't find Something's Cooking in My Kitchen by Donna on Spotify.
It's no Donna. Cow.
I guess many of you have also been using Google Translate, which is a very nice translation tool that has been improved quite a bit over the past 2-3 years. Maybe 2.5 years ago, they really improved in performance, and this is because they switched to a general deep learning approach where they're not learning only on individual pairs of languages, but they use all languages at the same time for training of deep translation software. If you look into Google Translate today, a lot of the things can be translated automatically, and it typically requires only a few changes in the output, such that you have a very good translation. So these are exciting, high-profile applications that we have seen with deep learning today. So next time on deep learning, I want to show you a couple of things that have been happening, not just at Google and the very big players. Actually, there's also in the small town of Erlangen a couple of exciting developments that I think are worth showing. So I hope you liked this video, and I hope to see you in the next one. If you have trouble following videos like over the entire scope of an entire semester, we are also offering the opportunity of subscribing on various different channels. So if you're a student of Friedrich Alexander University Erlangen-Nuremberg, you can subscribe on the FAU video portal. If you need a little push watching these videos during the semester, we also offer in addition a regular update service where we advertise those videos in the sequence that you're supposed to watch them during the entire semester. So if you follow me on Twitter, LinkedIn, Facebook, I will also send out small messages when you're supposed to watch the next video, and I hope this helps in order to be reminded of watching the next video during the entire scope of the semester. We have to see whether this works. Note that if you don't like videos and you neither like the meme version or the meme-free version of these videos, we are also offering a complete transcript of this lecture that has been generated with our Autoblog toolchain, and we will also post the transcripts of the lecture right below in the description of the video, and you will also be able to read them. Everything that we are doing here in these videos, in our lecture material and so on, we publish under a Creative Commons license. So this is CC BY 4.0. This means you can also freely reuse anything that you see here in this video, so on the lecture slides, they are also available for modification. So if you want to build on the contents or if you want to reuse some of the images, that's perfectly fine. The only thing that we are asking of you is that you're actually citing the original source. Okay, so I hope you enjoyed this small video and looking forward to see you in the next one. Bye-bye.